Today, we are pulling back the curtain on something really fundamental in making physical products, especially clothes, actually. It's called the tech pack.
Ah, yes, the tech pack. Crucial stuff.
Right. It sounds technical, and it is. It can literally be the make or break document between a designer's idea, hitting the shelves perfectly.
Yeah, total chaos on the factory floor, big financial headaches.
Exactly. So, okay, let's unpack this thing. Our mission today is to give you a really clear, detailed look at what goes inside a tech pack. Why is this document, this blueprint, so critical?
Mm.
By the end of this, you'll basically be fluent in this hidden language of production.
And what's really fascinating right from the start is that even though tech pack sounds super official, there must be some global standard.
There isn't one, really.
Nope. Our sources are clear on this. There's no single official international standard for a tech pack, which, makes you wonder.
Yeah, how does anyone agree on anything then? If you've got a designer here, a factory way over there, how do they know what needs to be included?
Well, that's the interesting part. It seems like it's a case of industry practice trumping formal rules. The sources say there's a strong general agreement on the types of information that are absolutely necessary. There are about 10 generally accepted parts, even if companies structure them slightly differently. Let's start with the basics, the kind of admin stuff and the visuals.
Sounds good.
So component one, the header, right?
It just needs to clearly label the product style, maybe a season code, the version number that's important for tracking, changes basic admin details.
So the factory knows exactly what they're making and which version of the instructions they have. Crucial for avoiding using outdated specs.
Okay, so after the cover page, things get more complex fast, right? Component two, materials and trimmings.
Mm-hmm. And this isn't just, use cotton. It's exhaustive. Every single physical thing.
Like every single element, down to the tiny bits.
Oh, absolutely. Your main fabric, sure, but also the lining fabric, any interfacing, the specific thread color, thickness elastic, buttons, zippers, and critically, all the required trimmings and labels.
Labels seem like a small detail, but I guess they matter hugely for branding and compliance.
Massively. Think about it. A designer might specify, say, a special woven brand label inside the neck. If they forget to list the exact label and its placement point here in this section,
the factory might just leave it off.
They might. Or put it in the wrong place. Then your whole shipment could get rejected during QC because it doesn't meet branding or legal requirements. All from one missed line item in the materials list.
Wow. Okay, so that little detail suddenly becomes a massive potential problem.
It really is. So once you've listed every single nut and bolt, material-wise, we move to component 3. This is the visual core. The flat sketches.
And these aren't the pretty fashion illustrations, are they?
No, definitely not. These are technical drawings, like blueprints for a house, but for a garment. Detailed, precise, usually done in software like Illustrator.
Showing it laid flat.
Exactly. Front view, back view, sometimes side views if needed. They have to clearly show where the seams go, the type of stitching visible on the outside, top stitching, placement of pockets, buttons, zippers, everything.
Why flat? Why not on a figure?
Because the pattern maker needs to see the pure geometry and proportions without the distortion of a human body. They take this 2D flat sketch and figure out how to cut the fabric pieces the pattern so it becomes the intended 3D shape when sewn. It's the foundational map.
Okay, that makes sense. It's the engineering drawing.
Precisely.
So that covers the what it's made of and what it looks like, flat. Now we get into the how, right? The engineering, the construction details.
Exactly. Section 2. This is where precision becomes absolutely paramount. Get this wrong. And you're not just making something slightly off, you're potentially making something that fails.
Or costs way too much.
Right. So component 4 is where it gets really granular, you said. The assembling details.
Oh yeah, this is the micro instruction manual. It's fascinating, actually. You go deep into every single join and edge.
So you can't just write, sew sleeve to body. That seems obvious. If only. No. Especially with performance wear or complex garments, you have to specify which type of seam. Is it a simple flat seam? A French seam for a clean finish inside? A super strong safety stitch for sportswear?
Ah, different seams have different properties. Strength, stretch.
Exactly. And appearance. Then you have to detail the types of stitches, like a lock stitch machine versus a chain stitch machine. One has very little stretch, the other is designed for it.
That seems incredibly specific. What happens if you mix those up?
Well, imagine specifying a non-stretch lock stitch on the seam of a really stretchy yoga pant.
Pop, the seam breaks first time someone moves.
Instantly. Big quality fail. But it's also about cost and time. Different stitches use different machines, different amounts of thread, and take different amounts of time to execute. Specifying a complex, slow stitch when a simpler, faster one would do the job.
Adds seconds to every single garment made, which adds up hugely over a production run of thousands.
Absolutely. Blows out your labor costs and your delivery timeline. So getting these assembling details right, the seams, the stitches, the finishes, like hems or cuffs, it's a direct link to quality and profitability. Minute details, potentially million-dollar consequences. It's not trivial.
That really drives home why that level of detail is needed. It's not just fussiness.
Not at all. It's risk management.
Okay, speaking of precision and managing risk, component 5, this sounds like where the numbers really come in, measurement control.
Yep, the math part. And it's more than just listing sizes like small, medium, large.
Right. You need the actual measurements for each size, like chest width, body length, sleeve length.
Correct. Often shown on a diagram called the point of measure or POM sheet, showing exactly where to measure on the garment. But that's only part of it. You absolutely must include the tolerances.
Tolerances, that's the acceptable variation, right? And deciding that tolerance, that's a balancing act.
Huge balancing act. It's a business decision, really. Demand a super tight tolerance. You're asking for near perfection.
Which means
Slower production, potentially needing more skilled workers or better machinery, maybe more garments, failing quality control. All adds cost.
But if you make the tolerance too wide, too generous,
Then your sizing becomes inconsistent. Customers get annoyed because a medium bought today fits differently from one bought last month, high return rates. So the tech pack locks in that acceptable range, balancing cost and quality.
Okay, quick question here. Since there's no global standard for the whole tech pack, how does this measurement and tolerance section hold up legally, like in a dispute between a brand and a factory?
Oh, it's absolutely central. This part of the tech pack effectively becomes the specification agreement. When the buyer inspects the finished goods, they measure them against these specs and these tolerances.
So if the factory delivers shirts where the chest measurement is consistently outside that plus or minus half-inch range,
The buyer has clear grands documented right here to reject the shipment or demand rework. It's the key piece of evidence for adherence to the agreed quality standard.
makes perfect sense. It becomes the contract for the physical product specs.
Precisely. And the other critical piece of component 5 is the grading range, or grade rules.
Grading. That's how you scale the pattern up and down for different sizes.
Exactly. It's the set of mathematical rules that dictates how much bigger or smaller each measurement point becomes between sizes. Good grading ensures that the small looks proportionally the same as the extra large.
So your Excel doesn't end up looking weirdly stretched or distorted compared to the sample size.
Correct. It maintains the design integrity and intended fit across the entire size run.
Yeah.
Super important for customer satisfaction.
Right. Okay, that covers the real nitty-gritty of construction and sizing. Let's move into the next section, which seems more about logistics and, crucially, the money side.
Yes, planning for actual production and making sure it's financially viable.
So, component 6, the color range. Sounds simple, maybe. Make it in blue, black, and red.
Not quite so simple in practice.
Yeah.
Yes, you specify the range of colors, often using standard codes like Pantone numbers to ensure consistency. But the real complexity comes in detailing the combination, meaning if you have a jacket with, say, a contrast color lining or different colored panels or specific colored zippers and buttons for each main colorway, you need to specify exactly which trim color goes with which fabric color.
Ah, so for the blue jacket, use the navy zipper and silver buttons, but for the black jacket, use the black zipper and gunmetal buttons. That level of detail.
Yeah, precisely that level, often shown in a colorway matrix or chart. You can't assume the factory will guess correctly which combination looks best or matches your intent. You spell it out.
Okay. And all this detail we've built up, materials, trims, assembly, colors, it all feeds into the next big one, right? Component 7, the bill of materials.
Absolutely foundational. This is essentially a recipe list, but for manufacturing. It lists every single material, every trim, every label identified back in component 2.
And crucially, the quantity needed for each one.
Yes, the quantity per garment. And its purpose is very specific, to allow for the calculation of the complete cost of producing one unit of that style.
All right, we're nearing the end. The last few components fall under additional information, right? Kind of the supporting details to ensure everything is crystal clear.
Exactly. These are often about capturing the nuances, the aesthetic intent that maybe the purely technical specs don't fully convey. So component 8 is often inspirational pictures.
Wait, if we have the super precise flat sketches, why do we need inspiration photos? Isn't that redundant?
Not quite. Remember, the flat sketch shows the 2D geometry. But it doesn't always perfectly capture, say, the drape of the fabric or the intended volume or silhouette.
Ah, so the photo helps show the feeling. Like, is this meant to be a stiff, structured jacket or a soft, flowy one?
Precisely. It gives the pattern maker and the sample room visual cues about the desired end result, the overall shape, and how the material should behave on a body. Helps interpret the flat sketch correctly.
Okay, that makes sense. Visual context. What's next? Component 9.
Component 9 deals with any artwork for decoration. If your product has a graphic print, an embroidery design, a heat transfer, anything like that.
You need to include the actual artwork file.
Yes, the print-ready final artwork. But also critical specs. The exact position on the garment, often using coordinates, like X inches down from next seam, Y inches over from side seam.
Super precise placement.
Has to be. And the specific colors to use within the artwork, often referencing Pantone codes again. And the technique, is it screen printing, digital printing, embroidery, applique? Each technique requires different setup and produces a different result. You leave nothing to interpretation when it comes to branding or graphics.
Got it. No room for error there. And the final piece, component 10.
The last logistical step, packaging. How should the finished product be prepared for shipping and retail?
You mean like how it's folded?
Exactly.
Yeah.
How it should be folded, whether it needs to be put in a poly bag, if it requires specific hang tags or price tags attached, how many units go in a carton, any specific carton markings.
Yeah.
All the final steps to get it from the factory floor to the distribution center or store correctly.
The job isn't done until it's packed properly.
Right. It completes the whole cycle.
Okay, let's zoom out then. What does this whole deep dive tell us? A tech pack clearly isn't just a simple list. It's this incredibly detailed, multi-layered document.
Absolutely. It covers everything from, the type of thread and stitch we talked about in component 4.
All the way to the final cost, and even how it gets folded into a box in component 10.
It forces the design side to think like engineers, like logistics managers, like accountants, all at the same time.
And bringing it back to that point you made at the start, the fact that there's no single international standard for this document, that's still wild to me.
It is, isn't it? But it highlights how vital these shared, even if informal, industry practices are. The fact that manufacturers globally rely on getting these types of details.
It suggests that trust and really, really comprehensive detail are the only things that work when you don't have a rigid universal rulebook.
Exactly. It's become the de facto standard through necessity.
Oh.
This level of detail is the common language.
Lingua franca of global manufacturing.
That's a perfect way to put it.
Okay, so before we wrap up, let's leave our listener with something to chew on, a final provocative thought.
Right. So we've really hammered home how crucial that bill of materials component 7 is for calculating the total cost, right?
Connects design to dollars.
Okay, so think about this. Imagine just one small ambiguity slips through earlier. Let's say back in the assembling details, component 4, the description of a particular seam type isn't perfectly clear. The factory has to make a judgment call. Maybe they choose a method that's slightly slower, uses a different machine, or needs a bit more care than the designer intended. Just a few extra seconds per seam, maybe?
Seems minor in isolation.
But now, think about how that tiny, ambiguous detail born from unclear documentation in component 4 could ripple through and potentially shift the final cost calculated by the biome in component 7, especially over thousands of units.
Wow, yeah, that seemingly tiny imprecision could actually make the whole product unprofitable if the margins were tight.
Exactly. It just underscores how getting that documentation absolutely perfect before a single stitch is even made. Well, it's literally the foundation of whether the business works or not. Makes you really appreciate the pressure to get it right.